Welcome everybody. Now talk about computer programming review. We talk about the upcoming midterm exam that we have to do it, right? So in this midterm exam, we will cover, you know, 5 chapters. The first one is Introduction to C# Programming. Is all about Fortran or something like that, right? And about chapter 2 is all about data types and variables. Chapter 3, Explanation and Operator. Chapter 4, Making Decision Part 1. Chapter 5, Making Decision Part 2. All right, let's get into it. So here's the quick review of mine, right? Just try to help. Here's the chapter number 1, Introduction to C# Programming. Let's see what it's all about. It's all about pseudocode and flowchart, right? Here's talking about the algorithms, right? Algorithm is a represent of a solution to a problem. A computer program describes a computer procedures as algorithm. Think a bit like, you have instruction, right? First one, what you need to do here, and the second one, and the third one, and so on, right? Before beginning to code, we first design algorithm to understand and analyze solution. It quite makes sense here. Here is the algorithm. Before writing a programmer must clearly understand the desired result. First, you need to understand what you try to do here, right? Because computers have no idea. So you would be the one who tell them what to do. And, to understand the concept of algorithm, we have pseudocode and flowchart. Those things will help you to understand yourself, if I would say. And when you understand yourself, you can tell the computer to do whatever you want it to do, right? And here's the computer programming just right here. We have input here. We have process that we can we can process, we can calculate something here, and then we have output, right? Think of it like you go to Google and you type something and you place enter, right? And it will show you something. Here's the output, here's the input, right? And now I'd like to talk about pseudocode. So is a simple sentence that explains the process of algorithm. It uses a simple English word to represent actions. For example, you might use print, you might use display, you might use set or if else or get or something like that. But it don't have to be exactly like print. You don't need to do that. I might say white, right? So it's quite makes sense here because print and white, yeah, you might want to write something out of the screen, right? You want to show something into your terminal, so you use this one. It could be anything that you understand yourself, and hopefully your colleague would understand it too. And if you want to read something from user, you will expect for input from user. You may say read, right? Or you can use anything else like input or something like that. It's totally up to you. And here's the flowchart. Flowchart is a diagram that shows the processes of algorithm. So you have full line here, full line, and you have terminal, you have process. When you want to calculate something, you use this one, right? Like, square-ish shape. And this one, you use this one. And this one, you use the diamond shape one. This one, you use it for input and output. And this one, you're going to use it for decision making when you have to make some decisions, right? You're going to use this shape. And now we have 3 basics algorithms for you to understand how it works. I mean, the pseudocode and flowchart, right? And here is the flow chart right here. This one represents sequence. So when you think about the sequence, you think about the 1, 2, 3, 4, right? Think a bit like the instructions or something like that, or some sort of it. And the flow chart that you have here is quite straightforward. So it's go from here to here, right? It's not like a straight line, nothing complicated about it. And here's the decision. You have condition. You may have condition like if your age is more than 20 or equal, right? So you can go to the club or something like that. And when you ask something like that, you may have two outcomes, right? Or more than that. But in this case, we have two outcomes. The first one is we'll go to statement 1, and the second one is go to statement 2. If it's false, right? And if it's true, it's go straight to statement 1. So it should look like this. So you have start here, and you have print something, how old are you? And you expect that user would input something, and you will read 8 from the user. And then you have decision here, the diamond shape is here. You say if your age is more than 20 or not. If it's more than 20, you will go to this statement, right? It's just to print you a teenager. And what if it's false? If it's false, is go to this statement to say you are not teenager anymore. Hang on, let me check. I heard some sound. Oh. And for the third one is a loop one. So you have some kind of condition here, right? And you will do something. If it's false, it will go to, it will exit this loop. But if it's true, it will do something, and it will loop back to this position again. And it will go through this condition again to check if the condition is true or false. What if this sum is false? Is just exit this loop, right? It's simple as that. If this condition is still true, it will go through statement 1, and it will go back to this point again. So it's some kind of loop, right? When you look at the flow chart, you see start here, and you set n to 1, then you say hello. Then you will say, all right, now n equal to n plus 1 right here, and you have a condition just like this one, right? You say if n is less than or equal to 10 or not. If this one is true, it will loop back and do this one again and increase the n value by 1. And it will do something like this, probably 10 times, right? And then it will say it will end this program. It will exit this loop through just like this branch, right? Go to another statement, and that another statement say end. So it just end like that. And now we talk about C#, right? When we talk about C#, we have structure, and the first one, at the very first one is all about its library. So this one you don't use much, right? You use only the console.yline. So all you want is just using system, right? Because you don't want something else, just like the HTTP request or to calculate some cryptograph or something like that. You don't need it here. Since you don't need it, you need only one of them, which is a using system, just right here. And you have namespace. Namespace, it's just like, when we're talking about the object-oriented programming, we tend to think of it like something that exists in our world, just like, I'll show you. Hang on. All right, here. Just like this book, right? We have space for them, and I say here is the space for them, just like this one. And we have class. in the space we have object, right? And that object would be, okay, the same one, my book. And what my book have here uh, is attribute, right? Is cover. So I may have variable, say that I have cover and is equal to something, and I have something inside, right? And I have page number, right? When I want to read something from it. And I would have the main function. The main function means it's just the entry point of this program. When this program is run, what is supposed to do first? So it will go straight to this function called main function here. And you may have something like this. You may have statement inside, right? What you want it to do. And, you know, in the after the midterm examination, you will learn about method, or you could call it function, or whatever you want to call it. So let's say we have this object and I call it book, and I have a several method here. For example, I can open it, right? Just open my book, and you know, I can, you know, scroll around to turning the pages, and those things are methods, and you will learn about it in after the midterm examination. So don't worry about it yet. And here is basic C# syntax. So it would be nice if you guys know that C# is case sensitive. So you might see those two, they may look similar, right? But they are different because this one is the capital one, but this one is non-capital one. The curly braces, just like this, marks the beginning and the end of the block of the code. So you're gonna need this one to tell your compiler, right, what is the beginning and when it's gonna end. And oh, sorry. An executable class must have a method main. So just like I told you before, you go straight to this method first because it's some kind of the default method for C# or something like that. And we have general statements and expression end with semicolon, this one. And indentation is recommended. Is always recommended when you do the indentation, because it also helps you as a human to see the overview of your code, how it should look like, and how could you predict the outcome of this program, right? And it also helps your colleague to be able to read your code easily. So yeah, you're gonna need it. Just like that indentation, just like this. You see, this one is start at the very beginning, right? And this one have indentation, have indent, right, till here. And this one have a bigger indentation, right? Just start from here. But it's totally up to you because you might don't want it. So you tend to type it at the very beginning, and it's just fine because now we use compiler to compile it, right? It's not like the indentation sensitive, just like Python or something like that, that the indentation is very important for them, but not for the C#. And here's the dot operator is used both to access a method and data in class. So when you have class, you want to, you want to retrieve some variable in this class, you're gonna use this one. And just like this one, this one is the class, right? The class is named console, and you have method called white line here. And when you want to access it, you need this symbol or dot. And you say white space doesn't matter. Yeah, of course it doesn't matter. It's the compiled language, right? And here's the shopper too. Now we talk about data types and variable. Here, data type that you have at the root, node, right? You have C# type, and it's split into two types. The first one called value types, and the second one called reference types. And you may familiar with this one, right? Because you have integer, you have unsigned integer, and you have floating point, you have double, you have a lot of them here, right? That you're familiar with, just like this one, or Unicode characters or char. You have boolean here to store whether it's true or false, right? And how about this one? How about reference types? You have class, and class have object, right? It's have string here, it's have some user defined value here, and you also have interact part, you also have array, and you also have delegate part as well. But that's not all of it, I would say, because it might be missing, but I just want to say, because it will help you in the future, because you also have something called pointer. Pointer will point to a specific location of your random memory. So it would look like this, OX something. Hang on. Yeah, it should look like this. So it's point to somewhere in the memory. So yeah, just Google about it and you will see. And here's the type that I want to talk about. The first one is Boolean, and we have char here to store the character. Boolean, we store the Boolean, even true or false, right? And we have byte here. 1 byte equal to 8 bits, right? And the maximum value that you can store is just like that, 2 power by 8 minus 1, right? And this one is look like byte, but now we have sign byte. If you need sign, you need to sacrifice the very first bit that you have, right? To say whether it's a negative or the positive. So the value that they can store, it's just the same length, but now it start from the negative one. Here the short one. Short one is the 16-bit. So when it's 16-bit and it's is designed integer type. So this one start from minus something to to positive of something, right? And you guys know how to calculate those values, right? I have told you guys many times before. I hope you guys can still recall it. And we have unsigned short here. The unsigned short, as you expect, it start from 0 to to this value. It start from 0 because now it's unsigned, right? When you say unsigned, you don't have the negative value. You don't have that part. When you don't have that part, you have one additional bit, right? Because you don't want it to say whether it's negative or positive, because you expect for the positive value. So it's how it goes. And now you have integer, and you assign one, right? When you assign one, you can expect for from the negative point of something to the positive point. Now is unsigned in. As you can see here, you can store double of this one, right? Because now you don't start from start from the minus of something. You start from 0, right? And here's the maximum that you can carry with the unsigned int. Here is long. Long is just double in size of the int one, right? So here's the maximum value that you can store here. Here's the unsigned long. You can see it's a very, very big number, but sometimes it's just not enough. And here's the floating point, and here's the value that you can store. And here's double, just 2 times inside of the fourth one, and here is the value that you can store in it. And here's the decimal. Decimal is the really huge one. As you can see, it's used 96-bit. Wow. And here is value that you can store in this type. But, you know, as I said earlier, that you want your program to be optimized, right? When you just want to store value, and you know that value range from, you know, 0 to 250, I would say, and you tend to use a very big variable for that. For example, now you use long to store just a very small value, and the problem is when you use this one, right? You can use this one, does the job, right? And you use this one, you usually 8 bits, right, in your memory. I mean, the memory space is much more less than this one, right? And it's worked exactly the same if you design it right. That's why I encourage you guys to do the optimization, because it's really important here when you work in your future, and you know, we don't want garbage, right? We don't like it. And here's the tips for choosing value types, and they have some guideline here. First, you say integer is good for store integer value. Yeah, of course, as the name suggests, right? And we have side type. If you have probability that your variable might be store something negative, you might use this one, right? Because you want to store the negative part as well. And when you want to store something that are way positive, for example, that date, right? For the date, it starts from 1 to 3 to 31, right? The maximum of it. And I'm going to use the unsigned because it's totally up to you. Sorry, just ignore my just ignore me. Here's the double type. Double type is for the point, but it's not exactly right? Because float can store floating point as well. But the reason that you need to use double types is because now you might need to store a big number that in floating point, right? Now you may want to use the double one. And here's the shard type. It's a Unicode or escape sharders encoded by single quote mark. So you have single quote right here, right? And here's A, and here's probably A too. I have no idea, but it could be. You can check it. And here's the escape selector. When you want to, you want to print out single quote, right? But your compiler might think you want to open some code or something. You need to help it a little bit by using the backslash here and followed by the things that you want to print out. For example, it's all about a special selectors, right? This one and this one and this one for a new line, right? You guys know it. You can just use this one for a new line. And here the string is look like this. It store the array of the selector. So when you watch carefully, you have selector here, right? And here and here and here and here. When you have it is the array of the selector. Now they call it string. So now you can store more than one selectors, right? More than one. And here is the cost name, and you have something like this. And you can also concatenate, which means you can connect them. You can connect the string 1 and string 2 using the plus sign here, just to say, all right, you want to connect something. So the compiler will check, oh, all right, course ID, all right, string plus with the spacebar, right? So whatever inside here is a string, and it's plotted with string again. So it's quite makes sense that you can concatenate them together. And here is the output. It should look like this. Here, how can you the carrying variable, and you have variable type here is either, is either integer or char or float or double or long or whatever. It's just a type, and you say type here, and then you have spacebar here, and then you name it, right? The name that you want to give to those variable. And here's how it should look like. You say the carrying multiple variables. Yeah, of course you can do it. At first we do something like this, right? But we can also do something like this as well. It's equivalent to int A, int B, and int C. So in this similar fashion, this one will go like that. And this one is look very similar to this one, but is also assign its value to 0 as well. It's equivalent to this one. And sorry, over here, stop it here. And we have integer x and y, and we say x equal to y and is equal to 0, which means x will equal to 0 and y will equal to 0. And it said here, all variables should be initialized. Of course, when you say something like this, right? Actually, you can print it out even if you have not assigned it value yet. But in some language, for example, for C language, when you do something like this and you print it out, you will have some random values, and you don't want it in your program because they're unpredictable. Or even if you have the next line, say, B or A equal to, let's say, convert to something, and you read the user keyboard, right? You try to use the, what is a lead line, right? In C# they use lead line, and even if the next line say lead line and A equal to something, you should not trust it. You should assign it value to be in the safe side, right? Because you don't want your program to be unpredictable, and it's very tough to debug it if you not initialize that. So we recommend you guys to initialize it first. And here's the integer. So we have underflow and overflow. As the name suggests, for example, overflow, which means you add something too much into a limited space, right? And it's overflow, just like you do with the water and glass, right? When it's overflow, it will go like this, and when it's underflow, it will go this way, right? To here. And you have to keep it in mind that the negative value, I will give some random example here. If I say 0 first, right? 0, and I go with this, I might have, right? Because it could be anything. And we say you might have 5 here, and what if you want to say -5 here? What you going to do, right? You may say something like this. So this one changed from 0 to 1, right? Which means the sign is changed. It should be go to -5 right here. So as you can see, when you have the limitation of the number of the bits that you can use, now you can underflow it, right? You could not add more to this number because now it's full, right? So it follows a similar fashion, just like that. So you have something called underflow. And when you say, all right, no, they want to test the underflow and overflow, right? Let's say you have S byte or psi byte, and the length that it can store is go from this one to this one, and now you assign S byte X equal to this one, and you print it out. This one should be fine. This one should print out like 127 or something, and then it's at, right? It's a X plus plus or X equal to X plus 1. And now, as you can see, is overflow, right? Because the maximum number that it can store is this number, but you added by 1, and here's what you got. And here's the example of the underflow. Here's the maximum negative value that you can have with this data type. And then you say you want to print it out. And this line, it should be fine. It should print like -128. And when you minus it again, y minus minus or y equal to y minus 1, what you have here, that they call it underflow, here's what you should get from this statement. And yep, now we have console.yline, right? The one that you guys familiar with. It's just like printf, right? In the C language, that everybody in this earth, when they want to learn about programming, we will say printf hello world, right? Is it's classic and it's lovely. And we have console.readline here. When you see something like this, you expect for the input from user, right? It just like keyboard or something like that. And in the C#, when you want to read the data from users, and it's a accept data in string form, all right, so it should be string, right? It should be something that user type on their keyboard. And here's how it goes. It's a console.readline here. It's a, you want to read something from user, right? You expect for the input from user. But in C# is they love to make things more complicated, more than it should be, I would say. Or it could help you when you want to write something a bit more sensitive or a bit more impact. So they don't want to do the auto convert or something like that, because it could be something you don't want it to do, right? So yeah, I'm sorry, Microsoft, I should not say that. But yeah, I would say how it goes, right? How it work in C# here. We have number here, say is equal to convert to int32. Here's the function, as you can see. Here's the function, right? And it's a console readline. Inside is put this one as its argument, and it will convert whatever here is. It could be string of 100, right? But it's not equal to 100, because this one, you can see, you see double quote here, right? Like I mentioned earlier, what inside double quote here, they call it string. It's not a number, it's just a string. When you want to calculate, you could not use this one because it is a string. It's just not 100. It's not equal to 100. But when you want to calculate it, right, you may want to convert this one to this one, right, to actual 100, that you can do the arithmetic operators with it, just like plus, minus, multiply, or whatever you want. And here's the C# output. When you want to print out something, you might use this one, say console.write here. So they have a small difference here. This one say they will print data without printing the new line, but this one say is a use to print data with printing the new line. So this one, and if you want to make things complicated and you learn, right? It goes like this. When you say something like this and you have your data here, right, is equivalent to this one. So this one is basically, it just add \n, at the very end of it, right? Here's this job is really small different here. And is used to print data, is print a new line. Oh, here's the example of it, right? And what's this? It's a 1 h equal to 19. I don't know what it's supposed to mean, but all right, let's get into it. This one say int a equal to 10, int b equal to 20, and it say int c equal to a plus b, so c equal to 30, right? And it's a console white line, a equal to a, right? Makes sense. A equal to a, and b equal to b. A here, it should print like a equal to 10, b equal to 20, and c equal to 30, right? C here, they're the same. But this one, I have no idea, but I can guess, right? It's probably, they probably want us to say what is data type that it should use here, right? And the first one, when you have this one and you think, yeah, you might want to use unsigned byte, right? Or you could use, a smaller variable type than this. But in general, you can just use integer here or int here, right? Because it's differently covered. And as you can see, the hardware nowadays, they're super powerful, right? You may have a mobile phone that say you have 16 gigabytes or something like that, but this one say is need 32 bits. So 32 bits is just like 8 bytes, right? It's not gonna have some impact to your computer because your computer is super powerful nowadays, I would say. But when you think about the general programming, yeah, it's worked that way. But when you work in industrial or something that every bit count, every byte count, just like in the cryptocurrency or in the smart contract, you might have to think it more carefully. But in this class, you can just use int here and it would be fine. It's just all right, And this one say b equal to 1.2, and as you can see here is the floating point, so you can do it float here and it should be fine. And this one say name equal to Lisa, and this one, right, the double quote here give you a hint that this one should be string, and this one is Boolean, right? It's true or false, so you could use Boolean here. And this one say alphabet equal to E. Alphabet equal to E is give you a hint here. Alphabet just E, right? Just one of them, and they have single quote here. They're definitely short, right? You can use short here. And this one say number equal to 555.78 is just a little bit tricky because when you see only this part, you might think, yeah, they are floating point. I'm gonna use 4 here, but no, you should not do that because the double quote here give you a hint that they are string. Like I said, this one is not equal to this one, so carefully, guys. No, they are not the same. And here's come to the chapter 3, explosion and operator. Here the C sharp arithmetic operators. Arithmetic is something to do with the number, right? When you want to plus, you want to minus, you want to, do some logic operator as well, or even assign. When you want to assign something, you use this one, equal, right? Just one equal. And when you want to calculate something, of course, you're going to use something that you use in your real life, right? In your daily life, that you use the plus, you use minus, and you use multiply, or something like that. This one is mod, right? Divine. And here's the conversion operator. When you want to compare one thing to another thing, you might want to use this one or this one. This one say if it's equal or not, right? And this one say if it's not equal. This one say if it's more than. This one say more than equal, less than equal. And this one is the logical operators. And you have this one called and. When you use the logical operator, I would say think of it like a truth table, right? You might, I know you have learned about it. Come on. And when I say 1 and 1, you get 1, right? And you say 0 and 1, you will get 0. Simple as that. And this one is used for or, just like that. Or 0 or 1. What do you have here? 1, right? And if you have 0 or 0, you will have 0. Simple as that. And what's this? Hang on, I forgot it. Sorry. Operator. Precedent. What that's supposed to mean? What that's supposed to mean? Oh, it should mean which operator should calculate first and which one should come first and which one should follow. Let's say, hang on, I have 3 multiplied by 5 and minus 1, right? And you say A equal to this thing. What C sharp is going to do is to multiply first. It will do the multiply first in the C language, I would say. And you will have 15 here. When you have 15 here, it will minus by 1. Now you got like 14, right? And what if you have this one? When you use this one, is you do whatever inside this one first. So you have like 4 here, and basically it's say 3 multiplied by 4. You get like 12 just right here. So careful with them. They're actually useful, I would say. And when you have assignment operator or this one, just a single equal just right here, which means left equal to right? When you want to write something to variable, for example, you have A here, A equal to 10, right? So left equal to right. It quite makes sense here. And when you say variable equal to data or variable equal to variable, you can do that as well. It's not just like you need to assign only data to variable. You also can add variable to variable as well. But most of the time, you just copy whatever inside those variable to a new variable. And here you have integer 8 equal to 25, and you have string name equal to John right here. Then you have integer x equal to 8. So 8 is equal to 25. So x is equal to 25 as well. And you never ever try to do that like 10 equal to a or something like that. It's super weird. And I believe your IDE or your compiler might be crying, beg you to help, please fix it. Please fix it. Don't do that. You are so weird, something like that. Come on, just don't do it, right? we have arithmetic operators just right here. This one for plus, minus, multiply, division, right? It's easy to understand. This one as well. This one is used for modulus. It's a return the division remainder. Yeah, remainder, right? And this one say 5 mod 3. You have 2. Why? Why? Because you have 3 multiplied by this one could, could be anything, right? And you have come on, say should stay like this. Yes, it should stay like this. So this one is the integer, right? The positive integer only. So the maximum that you can go here is 1, right? So you have 5 minus 3. And how about this one? What you have here is the 6 and 3. Think of it this way. You might have something and you try to maximize this number, right? And now you can maximize this to 2, and you have 6 minus 6, and you have 0, right? This quite makes sense here. How about this one? You have 7 and 3 multiplied by whatever that we want to maximize it. And let's try 3 here. No, 3 doesn't work because it's over this number, right? Because this one will go to 9, and 9 is greater than this number, so it's not good. Even if you try to maximize that, then you try 2, right? When you try 2, and let's see what we got here. 3 multiplied by 2, you got 6 here, and then you have only 1 here, right? The only one remainders that have left is 1. And how about this one? Let's do this the old-fashioned way. 2 mod by 5, so it's hang on, 5, and you want to maximize this number. And what do you have here? When you try to input 1, no, it doesn't work because 5 is greater than 2, right? So it's a 0. So hang on, it doesn't work. Whatever I say. So this one is greater than this one, right? So you have 2, right? You cannot divide it. So when you cannot divide it, it is not divisible. So when it's not divisible, here is your remainder. So yeah, it's quite makes sense if you think of it that way. And how about this one? 5 with slash with something 2 multiplied by whatever, and you want to maximize this number. And what the maximum number that you can say here is probably 2, right? So it's a 5 minus 4, you got 1 here. Because now, if you want to try 3 here, you got 6 here. 6 is greater than 5, so it doesn't work here, right? So here's what you got from this statement. And here's the plus, or because increment. It's there you can say increase the value of a variable y by 1. And we have postfix. Postfix is this one is come after, right? Postfix. And we have prefix. Prefix come before. So what's the difference here? We have I equal to 3 here, and let me check my recording if it's still good or not. It's still good. And you have I equal to 3 here, and when you try to white line here, you will get 3, right? It makes sense. And when you have this statement will say 3 as the same, because this one, think of it that way. They have a hidden line, say something like this, right? If the compiler try to compile this code, is equivalent to this one, right? And this one is some kind of hidden statement that you can see it, but it's still there. It's there. And when you have this one, yeah, it's quite makes sense. You will have 3 here, but when you try to print it again, you will have 4 here, right? Because like I mentioned earlier, you have, think of it like you have some hidden statement here, say I equal to I plus 1. And how about this one? This one say prefix. It will increase the value first before it's print out or do something with those variable. Let's try double A equal to 1.5 here. When A equal to 1.5 and you want to print it out, right? What you expect from here is 1.5. It makes sense. And how about this statement? This statement, when you have postfix, right? Think of it like you have some hidden line, say A equal to A plus 1 here, just before this line, and you can just delete this line and it just work fine. You'll get the same thing, 2.5 here, right? I hope you can get some idea, like hidden statement, or you don't have to think like me. You can think a bit like, oh, this one come later, right? So it will do whatever with this one with the same value, and when those variable call next time, it will increase its value by 1. You can think of it like that. It's totally up to you. And this one we have increment, right? We have increment, which means we try to add it up, right? It goes like this. And here's the decreasement. So it will go like this, right? Go downhill. The same fashion, we have postfix and prefix. This one is prefix, and it say decreases just before use, and they say A plus plus is the postfix, so it will use before increases. And here's the example of it when we want to assign value to it, and we have integer x equal to 2 and we have y equal to 1. You also have u and v, which is the unassigned variable right here, and it's risky to use. Careful, guys. And this one say, but luckily we have not read it value, right? Because at the very first one, we try to write down the value into those variable. So lucky you, right? You don't have a problem here with those unsigned variable. No, sorry, it doesn't unsigned variable. Sorry, what a word is not initialized, right? You don't have the beginning value of it, just like this. You don't have it. All right, say u equal to minus x, which means the x will decrease itself before it's assigned to this variable, right? And no way. Oh, okay, sorry. Let's go from x, right? Minus x, which means x will decrease its value by 1 before assigned to this variable, which is u, which means u equal to 1, right? Oh, I probably can reverse my edit back, right? Yeah, I believe I can do it. So lucky me. I think I gotta mess up your materials. It's still good, no worry. And how about this one? This one say v equal to y minus minus. When you see y minus minus, it will decreases after this statement, right? So in this statement, you have the same value, and now v equal to 1. Simple as that. And here's the operator. You have those things, and I have talked about it before, this one as well. And here's the two table, right? You have P and Q. If false, think of it like 0, and true, think of it like 1, right? and you have several operators here. You have and here we say P and Q. P here is 0, Q here is 0, right? And you have 0. It totally makes sense here. And this one used for or 0, you got 0, right? And this one just not P. P is false, so not P is true, right? The opposite part of it. And let's try this one. Let's try one more case. And this one is supposed to be 0, right? And when you say true and false, what you have here is false, right? And when you say true or false, what you have here is true. It's just the basic truth table or the basic logic. I believe you guys know them very well. And here's the, precedence of arithmetic operators. This one, right? And what's this mean? I have no idea what it's trying to say here. Oh, it's talking about order, believe me. Order. When you have something like this, I'll show you. No worries. 5 multiplied by 10 minus 5. Some people may say, all right, this one equal to 45. Some might say, all right, this one is equal to 25. But when the C# type try to precede this statement, it will say, it will do something inside this one first. If it doesn't have this one, it will do the multiply and divide first, and then it will do plus and minus. So first we scan for this symbol. We don't have it here. Then we find this one. It will do this one first, right? So C# will interpret it to 50 minus by 5, and you got 5. Simple as that. But if you want to change its behavior in C#, you can do something like this. It's true that it will try to do the multiply first before do the plus and minus, right? But if you have this symbol, right, state that, all right, you need to do this part first. So C# you'll see, all right, I will do 10 minus 5, and I have 5 here, and then it'll say 5 multiplied by 5, so you got 25 here. Simple as that. Our operations normally operate from left to right, from this direction to this direction, right? If you're not sure, we use this one. Yes, I sometimes use it. And you have constant, right? I would say constant is the variable that will set at the compile time. So it's not part of the code, because this designed to be never be changed during the lifetime of the program. So we have keyword here, say constant. You must initialize value to constant at the time that you declare it. Just like this, you have constant here, and that constant is integer called fixed rate, and is equal to 5 here. And you can have something like this as well, the constant of int, and you have this one can apply to data value type and string. Yeah, and I believe they can apply to anything else as well. What we have here is we will have this string stored in somewhere of your no, I don't want to talk about it, it's too long. But when you do something like this, is tend to extract those things into a special part of your program. It is not in the main logical memory, just as this one. They are not the same. And this one, they want to keep it elsewhere. And you have this thing when you try to reverse engineer the exe. The reason that I have this information is I try to reverse engineer. Say we have cat.exe, right? And we want to see what inside the cat.exe. And you will see a lot of those constant things. You will see them. And it's just good for you to know that when you have variable and you don't want its value to be changed, so you can use constant, right? Simple as that. But sorry, I talking too much, so just ignore me again. And here is data type conversion. What's that? Oh, all right. You say when you want to go from smaller data type to a bigger data type, you can safely doing it. But when you implicit, it means you need to tell it something, right? The cast operator. All right. Here is the double here, and you have a here, which is the integer, and you want to store x into a, right? But now it doesn't work here, but if it's work, it's risky because you cannot predict its behavior now. But all the one thing that you can do is to cast it, to cast like say, hey x, could you pretend like you are integer? So now when you say something like this, the x will change to 1, 2, 3, 4, right? Let's say I am this number and I am double and I pretend to be integer. The integer will just cut the floating point part out, just like that. And the a will equal to 1, 2, 3. Simple as that. And why they put it here? Oh, they just want us to see the integer is smaller than long, right? So it should be somewhere around here. All right. Now we try to casting to integer, I believe. Integer. And basically you have two ways to do that in C#. You can either use phrased method just like that, or you can use convert. Here's the class name, right? Now you want to use method inside class name int, and this one you use method to int 32 in class name convert. To be honest, I tend to use this one because I had to remember the function name because no, stay here. And you know, I will give you some example so you would know what I'm talking about. When I say, let's say I use long, right? Long number 1 equal to long dot phrase, and you have console dot read line here, right? It's quite easy when you want to use it here. But what if you use this way? What is gonna look like? I show you. You have long, right? Number 1 equal to convert to what? Too long? No, it just doesn't work. If you say, I don't know this function name, or you say in what? Now it's 32. It should be 64, right? Or something like that. Here's you can guess, but here's this one is the correct one, I would say, but you need to remember it, right? It's 64. What you talking about, man? But when you say in dot phrase, yeah, I have some idea. I want to phrase something inside this one, and I expect the value to be int, right? And how about this one? I expect whatever inside here to be long, and it is just long dot phrase. How about this one? Convert dot to what? What what if now we have s byte? I would say s byte num2 and convert to what? I have no idea, right? That's why I recommend you guys to use this one because it's easy to use. It's much more easier. But they are the same. It's totally up to you which one that you're familiar with. How about this one? This one say, what do you want us to do here? Probably, no, I have no idea. All right, let's guess. Interior sum equal to 0. Sum plus equal 5 is equal to sum plus 5, right? So now you have sum equal to 5, right? Here. And I don't know what they want from us. And how about this one? Is we'll do this one first, right? Now this one will be 21. And it will do this one. And it will do this one. So you can expect for, 5 point something, right? I believe so. Let's try it. Oh, this one say is equal to 26. How about C sharp? I just would like to know, just out of my curiosity, I would say. And I will try. And A equal to, just want to try it out. And I'll say system dot white line, and we have A here. Please work, please. No, why? Oh, sorry. I'm supposed to say it like that. I don't know system. Oh, it's system.console with the capital C. I hate this one. To say white line. I hate you. Where's that? Oh, here. All right. Capital W. Yeah, you got it, Microsoft. What do we have here? 26. All right. I wrong. And I'm gonna see why. Mistake has been made. And we want to see why. All right, I believe this one basically is we'll do this one first. Is we'll do the division first, and it will multiply with this one. And lastly, it will do plus and minus, right? So it will do this one first. It will do the division first, and it will do the multiply. It will do this symbol, and followed by this symbol. So it's add up to 26. Okay. We'll fix this one a little bit, just like that. See? How about this one? Int value equal to 10, sum equal to 2, and it say, all right, let's rewrite it. Sum equal to sum multiplied by value is 10, right? So it should say sum equal to, we start from 2, 10 is probably 20 something. And this one, while console.yLine, and it say 2 equal to this one, and they are happen to be equal. So you get your Boolean back, right? I believe so, because this one is the comparison operators. So you should get like, it just depends on language that you use. Some language use this one, some use this one. Or some language may say 1, 2, right? And I believe C# will use this one, true. It is not capital 1. And this one, int A equal to 10. Oh, sorry. Int A equal to 0 and B equal to 1. And what this? All right, let's try. It's a plus A. So it starts from 0, and now it should be 1. And B minus, but it's come later on, and you got the same value. It should stay like 1 like console. A1 and B1. Here is the concatenate. See, plus. And how about this one? This one's a console.yLine, and you have this one plus with string. Oh my lord. What do you have here? Hang on. I would like to see as well. Oh, you don't have the type here, and I believe I can use string here. String A then. And I will see what is A now. Oh, I forgot semicolon. Now you have it. Oh, you actually have some value here. It's actually auto convert this one, right? It's actually convert this one to string as well. So to the arithmetic part, you have 40 here, and then it's converted it to string. So you have this one plus with this one, and your result is look like this. Amazing. And here's the chapter 4. What we have here is all about the decision, right? You have this one, you have if else, you have 2 ways now, right? And how about this one? You have if, else if, and else. You have 3 choices. Yeah, you can think of it that way. And this one, 1, 2, 3, 4 is a dot, right? It could be it's like every like that. So it's a many. Yeah, makes sense. And we have switch case, and this one can range from 1 to many as well. And you will see this one later on. And selection, you have if and switch, and you have iteration. Iteration means something that it will change when think of it like a loop, right? And inside the loop, you're gonna have a condition when to exit this loop, right? And they call it iteration. And you have jump. Jump is actually been something in the assembly part before it's converted to the machine code, right? It is actually say AMP oh to somewhere. It's actually happen like this in the assembly when this C# is compiled. But ignore me. Sorry. We have break here, we have continue here, and we have go to here, and we have return. So break here, which means we want to exit the loop, whatever loop it is, and we just want to exit it. We don't care. And this one say we will do this loop again, but we want to ignore. Hang on. You have the first statement, the second statement, and you have continue here, continue, and you have CCC here. The part that is will execute it will be executed in this loop, in this iteration, See, this row only, and is a this one, yeah, it will get executed. This one as well, and this one say continue. It will skip this one. It will doesn't care about this statement anymore, but somehow it say continue, so it will do those things again, right? Because now we are in the loop. Yeah, I will say something, but you probably don't like it, and I just don't care. And you have loop here, right? It could be for loop or it could be anything, right? And when it's hit continue, it will ignore this one, but it will go back to this statement again, and it will do the loop, right? And it keeps skipping this one. And how about we use break here? Break. What we have here, this one will get executed. Yep, this one as well. But when it's see break, and we have statement here, it will exit this loop when it see this statement, right? So it just exit, and it will do d, just like that. This one is go to. It's used for jumping. You can jumping to anywhere with this go to. And you need to make a section for them so they can know how far they would jump, right? And this one is for return. Return means if you have a function called cat, and you expect the integer for the return, here is the expectation of data type that you want to return from this function, right? And what if you have like integer? Oh no. All right, I'll say like this then. ABB, and you have return here, and you have CCC here. What it's gonna do is we'll do this statement for sure, this one for sure, and this one say return. It will end this function, and it doesn't care what state is inside now. Is my have, like you see, is my have loop here, loop. Is my have loop here, and it just doesn't care when it's hit return, or if you have the additional statement here. It is just ignore this part. When it's the return, it just exit this function and go back to the previous function that call this function. Most of the time it's the main function, right? Oh, I speak too much. Okay, come on, let's finish this. And you have if here, you have if here, and you have condition here. It could be anything, and you have statement, right? This one is look like the same. We have condition here, and you have else here, and you have a second statement here. You say, well, all right. This one say if this condition is not true, so this case is just ignored. And how about this one? This one say it will do this one, and if this one is false, it will do this one, right? It will do else one, and it also do statement 2 as well. How about this one? This one you have else if, right? You can see here, you have if here and you have condition 1. And when the condition 1 is not true, it will try to see the condition number 2. And what if the condition number 2 is not true, right? Is if what if it's still wrong, it's still fault, it will do the second statement here, right? If you do else from like default, right? If this one is not true, this one is not true, what you gonna do now? All right, we do this one then. Simple as that. Here the example 1, you use if here. Here is the flow chart. Here is the code in C#. As you can see, it's easy to perceive, so I don't want to explain anything here. And here, what's the difference here? So this one, when no, it's just aim. All right. Here, when you say no, you just want to print something else. That's why you have else here, right? It's gonna make sense. And how about this one? You have elif. You check this condition, and you check this condition, and here is the default condition or the else condition. So it will do something like this. All right. Let's say first it will say, all right, is x is less than 0 or not. If it's less than 0, it will print negative and it will end your program. How about this one? If you say x is equal to 0, it's try to compare, right? Compare x with 0, is it equal or not? If it happen to be equal, it will print 0 in its program as well. And what if this condition is not true and this condition is not true? It will just print positive, right? And you can just convert this one into this one by using elif right here. Here is the shorthand. It could mean the short version of the if condition, right? And you can have variable here, you have condition here, and you have this symbol, and you have what if this one is true, it will do this statement, and what if this one is false, it will do this statement. So take this one for example. We say minutes equal to 17, and you have string called result here, and the result is equal to, here's the condition, minutes is less than 15, and we have 17 here, right? So this condition is false. When it's false, it will say late right here. Simple as that. What now? What now? All right, they just want to compare. They say, they are the same. You could use this one or this one. It's totally up to you. And how about this one? Oh, it's probably want the output of this program, right? It's a plus a. Now a is 5 plus a is 6. 6 equal to b plus or not? I believe it should say this one go to 6, right? And this one is use the same value. 6 not equal to 5, which means it should stay like, if condition is false, it should go this one. And how about this one? It say if score is less than 50, then this way. All right, here some kind of test case, right? It's just want to know, all right, what if score is equal to 65? What you gonna do? 65. This one is not true. This one is not true. This one is true, right? Is to say you can see you 50 here. No, right? Because 50 is not less than 50. It just messed up. No, is go to this one, right? When we say 50 less than 60, yeah, now you have B. And how about 70? And no, this one is not true. Now you have B. And how about 110? 110. You know, it could be A++, but you could not have it because the maximum grade here is A. Just like in this class that hopefully most of you guys will have A, but some of you will have A plus. No, that was a joke. Here is the chapter 5, making decision part 2. What is the difference? Oh, this one say nested if. Nested. You see, this one called nested. You have this one, right? The condition, and you have condition inside condition. It is some kind of nested. This is called it nested. Or you can have, think of it like you have SQL, right? You have database language that you want to do something a little bit more complicated. You might want to use nested statement, just like you want to select something and you want to wear with something that you select from somewhere else, and they also call nested. I just want to point out what is meant by nested, right? And here it goes. Here's the condition 1. Where is that? Hang on. Condition 1, condition 1. I don't know what this means. Oh, you have statement here, C1. All right, here's your entry point. You entry to C1, and then when you have C1, and when the C1 is fault, it just go to nowhere, right? Just exit this statement. So this one is makes sense. Just go to in here, or connector here. It will go to somewhere else, but we don't care, right? And how about this one? If the C1 is true, it will go into this curly bracelets, right? And it will check for the condition 2, number 2, just right here. And if this condition is true, it will execute whatever inside, which is this statement, just right here. And what if it false? What if it false? We don't have the default case for that. So it just does nothing. It just go to fault. It just go to this connector, right? So this quite makes sense. What's this? What's this? It's a nested VS if else. Oh, all right. We'll see. Here's the entry point. Entry. I just want to give me myself some hint. It's helped me a lot. Entry point here. What's that? What you try to say here? Yes. Oh, all right. This one is supposed to be the nested one, right? Because it will see the outer, you will see the outer if first, the outer condition first, and if this condition is false, it just goes straight to another part of the program, right? And if this statement is right, it will check another statement. Yeah, this one is definitely nested. And how about this one? This one, if it's true, it does nothing. If it no, if it's not true. Oh, all right, all right. Let's say statement 1, and this one statement 2, and this one statement T, and this one is condition 1, condition 2. When here's this case, right? If elif, so you have only one chance to make it right. I would say you may have condition 1 here, and you may have condition 2 here, and this one is the default case. And you either go to C1, you either, if the C1 is true, right, you do whatever inside, or you may want to do this statement 1. What if this condition is true? You may want to do statement 2, right? Just only one of them. It's just only one of them. one at a time. And you know what? I believe this flowchart is useless. Don't think about it. It just makes you confused. It's not supposed to go like this. So just not compare it. They are different meaning, like completely different concept when you want to use them. And let's say, what's this? Enter any number between 1 to 10. Okay, 1 to 10. And I want to relate line something to the in 16. This one is should go to short, all right? But this one is in, whatever. And if number is more than 10 or number is less than 1, it will say wrong number. Yeah, of course, because it's out of range, right? Because the range is 1 to 10. And you have else here. You have else here. And this else is a if the number is in range 1 to 10, right? It will go to this else. And this one say if number equal to 9, it's a jackpot number and 9. And what if we type 1 to 8? You have say your number is this one, right? Yeah. If you say it, you can see this is the nested, right? Like I try to explain the concept why you call it nested. When you call it nested, because you have this one, you see the default case or the else one, and you have if inside the else one, right? You have condition inside the condition. When you see something like this, yeah, let's just assume it as a nested one. Right, and here's the 0. 0 is out of length, I would say. 0 is out of length, so you have this one, right? 8, you have this one, and this one you have this one, and this one you have a jackpot 1. Oh, just 3 slides. Try to explain nested. Oh, you are in a bad luck, but you know, forgot about it. Please forget about it. It's just make you more confused. Believe me. When you be talking about nested, it just we have condition inside the condition inside this curly bracelets, right? Actually, when we have this bracelet, I just want to click at it. How can I? Oh yeah, just go away. You have this one for start and this one for stop, but most of the case or in the basic case, you will have statement, something that you need to execute here, right? But if you have if, again, you have the condition statement again inside the curly bracelet right here. It's just like that. They call it nested because now if this condition is true, you may have like, say, okay, it's true. I go into this curly bracelet and I gonna have to check for this one again, right? If this one is true, I will do this one. But if this one is not true, I do nothing because it's nothing here, right? And it's nothing here. Simple as that. And now we talk about switches. Oh boy, how is go? Here state that now we want to use switch, and you're gonna have a variable, right? You have this variable. And if this variable happen to be equal as the constant one, it will do this statement and it will break. And what if this one not equal to this one? So it just skip this one, right? It will check this one. Oh no, it's not equal. Oh, see, it's equal with this case. When this case is equal, it will do statement 2 and break. I tend not to use it because I can rewrite it just using the if condition as usual, right? and it's just prevent me from the confusion as well. But what if you have a lot of cases, right? You may want to consider use this one because it's easy to read, much more easy to read than the nested one, or it's easy to, this one is hard to read, right? When you have like this one, and you probably have like this one too, right? A lot of them, and you also have else here too, and it might cause you some confusion, and you might consider use this the switch case, and yeah, it's going to make sense. And here's the default case, which means if this condition is not true, this one is also not true. How about this one is also hit, is always hit this statement because it's a this condition, because it's default, right? Like I don't have any condition else that I want to compare. You are the very last one, or you may think this one as the else, right? Else, it's not met here, it's not met here. I will do something here. And this one just do statement 3 and break. It say if met, this block is code is executed. Yep. If it's met, if this case met, it will do this, right? If this case met, it will do this, and if this case is mesh, on, no, whatever, it will do this, right? Look at the flow chart. It's a, and the entry point is here. It's a variable equal to constant 1 or not. If not equal to constant 1, it will go check for the constant 2. If it's also false, it will go straight to statement 3, because just like I mentioned earlier, you can think of the default case with the else one, right? So you execute this statement number 3 here. And here's go switch. It's for the example a bit. You have switch here, and you have the variable called choice here. And if choice is equal to 1, it will do this one. You are select choice 1. And if it's equal to 2, it will say you are select choice 2. But let me check the right chord is working. And what if it's go to the default one is equal to else 1, right? It just say, oh, you either use 1 or 2. Now you say something else, I don't know, right? And it will break as well, it will stop it. And do not forget break of the case, otherwise you will get the error. The error here is not come from the compiler itself, it's come from the IDE. The IDE try to prevent you from doing something fetching to the code. It just suggests you, it's not suggest, it's throw you a big error here. You can see it's a red one, right? It's a big error here. The IDE try to prevent you, or sometimes the IDE is not preventing you from doing that. It just depends on the brand that you use, right? It just depends on the company that implement that IDE. But for some time, the compiler itself will try to complain that you forget something and is not comply with the standard, so it just keep you the big error just like that. So just don't forget it, right? And be careful, if no matching plus no default case, then control fault through a switch statement. What did you mean? All right, to see this one, right, this one you have the default case, but this one you don't have it, and it will fall through without printing anything. Fall through, what is supposed to mean? Which means it does nothing, isn't it? I don't know, but the recommendation and the C# document recommend you guys to have this statement or this default cases, right? They encourage you to do that, but I have no idea what if I compile this one, but I don't want to do that. But they say fall through. It's probably mean it does nothing, right? But they say please be avoid doing this. I don't know. Sometimes I just don't want to use the default case, right? So I just leave it like that. And what if it's fall through? It's just fine by me. But yeah, just be careful, right? Just always put that condition, put that default condition always in the switch case. You may have just a break, that fine, right? You don't need to say console white line or something like that. Just break, just break out of this switch, right? But in this case, I have no idea whether it just can exit this statement or not. It can exit this switch or not. But you try it yourself, right? I don't want to do that. And this one say go to, right? Yeah, just like I mentioned, is we'll do this one is to go to case one, and it's we do this one and break, right? And how about this one is we'll do this one and go to case one and break, right? So this one you have break here and you have default value here, default condition here, and you have to print something and you break here, all right? And if cost is not equal to 0, you say please insert what is do I have to read it, sorry, I tend to skip it. You say cost equal to 0 and you have size, okay, 1 2 3, okay, and you say please enter your selection, and if I want this one, let's say I want a small one, the small one is cost, it start from 0, is plus with 25, so now my cost is equal to 25, right? And it say if cost is not 0, which means it's not free. When it's not free, it will say please insert coin. Okay, this make more sense. I got you. Just have a little bit confused then. So basically this condition say if the user need to pay for anything, right? Because you say 1 is will go to here, 2 is will say 0 plus with the 50, and is will plus with the 25 again, so 75 now, and it will break, right? Whatever. And this one is for decision making. Basically, you have two choices to be made. The first one, you use the if else, or you use the switch one. It just depends on you. As I confused a bit earlier that I talked about the switch case, right? Actually, they have some use case when you have a lot of statement like this, or you have the complicated statement like this is hard to read, you see. But when you implement it using the switch case, it's just clean. It's just easy to be read. And yep. How about this one? How about this one? And you have number here, right? It could be anything. And they say enter, oh, all right, sorry, I skip it again. Enter number 1. Okay. And this one should say system, it should have something like this, right? To fetch its value from user keyboard. And this one have this one as well. And they say white line, please select the choice in 1 increment, 2 decrement. And this one should be choice, right? Simple as that. So it will decide using this variable. So this variable should be exit here, and it will receive the value from user to be able to say, all right, is matched with the case one or case two or the default case, right? So yeah, suppose that. How about this one? Oh, yep. I have announcement for the lab test. Number one, the first lab test. And we have hint here. Hint here say you need to pay attention on the decision making part, right? And here's the check-in time. And here is the test time and how to complete the test. Is say online anywhere, so you don't need to go to the lab, right? If no computer, you can come to the lab room, which is those room, right? And remark cheating equal to 0 and missing equal to 0. Or otherwise, you may need to have the the medical certificate or something like that to indicate that you are sick at that time, right? So if you feel like you may want to miss this one because of the important business or you are sick or something like that, so please send us the email state that what you want to do now, and we will sort it out, right? And here's the announcement for the midterm exam. So the midterm exam will cover chapter 1 to 5, and you will have 50 questions, which accounted to 25% of your grade. Yes, quite a lot. And here's the date, is the Thursday, 13th of October. It's very soon, isn't it? So its duration is 3 hours. And here is the website that you can do the online exam, right? This one. All right. I'm talking too much. I'm so exhausted. So I'm gonna end this section as of now, right? So good luck on your examination and hope for the best. All right. Cheers. Take care. And